Hello, my name is Imran Aslam. Today I am going to give a demonstration on the tank blanket gas application. First of all, I will explain the installation procedure of the application setup file. If you have already downloaded the setup file from my website www.petrosoft.com, then you can simply double click on the setup file. The application installation utility will be launched on your computer. From the language setup, you can select the appropriate language and then press the OK button. It will take you to the next license agreement page where you can accept the agreement option and then press the next button. Again, it will take you to the information page. By pressing the next button again, it will take you to the page where it is giving you an option to create a desktop shortcut of this application. So you can always create a desktop shortcut of this application so that you can launch the application on your computer straight from the desktop shortcut anytime in future. Now again press the next button. It will take you to the final step where upon pressing the install button down below, the application will be installed on your computer within few seconds. Since I have already installed this application on my computer, I will not install the application again. Instead, I will just cancel the utility and go to my desktop where I have already created a desktop icon or shortcut for this application earlier during the installation. So on the desktop application icon, you can double click the application desktop. The application will be installed instantly on your screen. First of all, let's talk about the main menu bar at the top of the application. The first menu tab is the file menu tab. Under the file menu tab, you will find new, save and exit options. So for example, if you have closed this application and you wanted to initiate or start a new instance of the application, you can go to the file menu tab. Under the file menu tab, you can press the new button. The new instance of the application will be launched immediately on your screen. The next option button is the save option button, which can save the results of the application into the PDF file format, or you can print it out straight away from your connected network printer. The next option is the exit button to close the application. The next tab on the menu bar is the about tab, which you can review the basic brief information of the application and the developer. The next tab on the menu bar is the help tab. When you press the help tab, it will open up the application manual where all the detail, narrative and description and the guideline how to use the application and the options included in the application are explained in quite detail with all the pictorial representation. This manual comes along with the installation package, and you can always access the manual straight away from the help menu tab. Now going back to the main application, the next tab on the file on the menu bar is the link to my website where you can look for more chemical engineering applications. Now let's talk about this main feature of the application. This blanket gas sizing application is basically used to size or calculate the blanket gas or the volume or the amount of blanket gas or the inert gas that is required for the tank blanketing. So in the industry, in the process industry, all the tanks, most of the tanks other than storing the liquid or the product other than the water, mostly the toxic hydrocarbons or any other toxic chemicals or any fluid which are hazardous if it comes out to the atmosphere. The blanket gas or the inert gas is normally used to blanket at the top of the liquid vapor space inside the tank. The other function of this blanket gas is to equalize the balance, equalize the pressure inside the tank, especially during the decanting of the liquid out of the tank or filling in the liquid inside the tank. So the tank, it helps the tank to breathe in and breathe out the vapors when the tank is in service of removing the liquid out of the tank and filling the liquid inside the tank. So it helps to equalize the pressure inside the tank and prevent it from catastrophic rupture or any vacuum ingress or vacuum creation inside the tank. Also, it helps to prevent the oxygen ingress inside the tank, where the oxygen can be a very like a toxic or can create a hazardous or a flammable environment inside the tank after mixing with the vapors of the fluid which are present inside the tank. So this tank blanket gas has multiple functions and role in the industry for the safe operation of the tank. So it is always required by the process engineers to calculate the vapor tank blanket gas for any given tank under any given fluid service. So this application is based on the API 2000 standard. All the limitations and limitations and the requirements of sizing the blanket gas for any tank is based on the API 2000 governing procedure. So let's go to the main feature of this application. All the standard limitation and procedure has been incorporated inside this application to calculate the accurate volume of the blanket gas requirement. So here when the application will launch, it will have only one page. It has only one page. On the left hand side of the application you can see the input section where you can select the type of the tank, whether it is vertical or horizontal. You can select the type of the tank from the given option button over here in the input section, and also you can select the drainage facility provided along with the tank by the given drop down list. So the tanks are equipped with different kind of installation or safety features. Most common safety features which are provided along with the design of the tank is already enlisted in the drop down list over here, so the user can select an appropriate option. The next option here is the flash point, which is the flash point or of the liquid which is stored inside the tank. The two options are provided for the liquid flash point below 300 degree Fahrenheit boiling point and above 300 degree Fahrenheit boiling point liquid. So the user can select any one of the option accordingly. Then the next input section is the tank condition, where the user can select the type of fluid that is stored inside the tank. A complete comprehensive list of all the most common fluids are already provided in the drop down list, where the user can select accordingly from the drop down list. The next option, the next user input is the blanket gas use. So the blanket gas, as I have explained earlier, that normally it is an inert gas. So the user can select the blanket gas or the type of blanket gas that is used for the tank's blanketing servicing from this drop down list over here, where a couple of most common inert gases are provided in the list. The user can select appropriately. Then the next input is the pump off rate in gallons per minute, which is basically the tank draining or a liquid drain out rate or decanting rate of the liquid out of the tank. The pump in rate, the next input is the pump in rate, which is the amount of or the volumetric flow rate of the liquid that is going or filling in the tank. It is given also in the gallons per minute. Then the next input is the tank volume in gallons, tank diameter, tank height, tank width, and tank length needs to be provided by the user. The next input that is required by the user is the vapor relieving pressure in pounds per square inch gauge. Here the user need to provide the blanket gas pressure or the tank relieving pressure at which the tank is operating at the facility. To help out the user in order to fill in the appropriate unit of measures, a small calculation section is provided in the help menu over here. Once you press the help button, a small window will pop up where the user can actually convert the required unit of measures for the relieving pressure. The unit of measures, most common unit of measures that is normally used for the tank vapor pressure or pressure set pressure in the tank is provided in the list. So out of these units, the user can just simply fill in the required known unit of measure, and then it can convert into the respective unit of measures accordingly. So the user can convert the unit of measures, and then calculated value from this window can be later filled out in this required field of vapor relieving pressure. Now moving further, again the tank the temperature of the liquid, the normal temperature of the liquid, and the molecular weight of the fluid that is stored inside the liquid. This information is populated automatically upon selecting the appropriate fluid from this list of fluids that is explained earlier. However, the user can change the molecular weight accordingly if there is any changes or if it requires. Then again, the latent heat of vaporization is also filled in upon selecting the type of fluid. Again, the user can change it accordingly as required. Then the molecular weight of the blanket gas, again it is filled out or filled in automatically by the application upon selecting the type of blanket gas used from this drop down list as explained earlier. Once all this information on the left hand side input section is filled in by the user, then by pressing the calculate button, the calculation will be performed automatically, and the results of blanket gas requirement will be displayed in the respective field on the right hand side of the page under the results section. The other important thing here is that this application is dynamically developed in such a way that upon selecting or changing any user provided inputs, the calculation will be instantly performed or refreshed every time when the user change any input value or select any input values from the drop down list. For example, at the moment you can see the calculation is done with the message bar green at the bottom and with the caption OK on it, which means that there is no error found and the calculations were done successfully. However, just to show you that this calculation can be dynamically done or refresh every time when the user changes any input any time during the use of this application, the user does not need to press the calculate button every time. So to demonstrate that, I will just simply close this application and go to my file menu, press the new button and launch the new instance of the application. Here you can see that this calculation is not yet performed. So if I change any of the given input variables, for example, if I change the type of fluid inside the tank, the calculation will be performed automatically. Like over here, I have simply changed the fluid type. The calculations were performed immediately, while all the other information is already filled in. So basically the user can change any of the required inputs anytime after once all the required field of information is already provided. Whereas the user can change all these inputs anytime, as well as the user can launch the new instance of the application anytime when the application is required to be refreshed. So here on the under the results sections, there are the three different unit of measure is calculated or shown for all the in breathing and out breathing or the blanket gas calculation. The first unit of measure is the standard flow rate in standard cubic feet per hour. The next table here is flow in mass flow rate in pound mass per hour. The third column here is is calculated the standard cubic feet per hour of flow at the operating temperature and pressure of the tank. So the standard flow rate is basically converted into the cubic feet per hour flow rate or the actual volumetric flow rate at the given conditions of the tank for temperature and pressure. Okay, so the next section there is another small calculation block or a section is provided at the bottom right hand side of the application by the caption of this calculation block. It says vendors valve capacities verification, which means that basically this section is developed specifically in order to validate or check the vendors provided valve capacities for any given fluid service of the tank. So normally what happens is that the process engineer can find multiple available valves from the vendor's catalog, or the manufacturer can offer any valve for your required service at the site. So the vendor's calculation or the standard valve capacities are given in two different flow measurement. The first measurement is the valve capacities based on the free air capacity volume. The other measures for these vendors valve capacities are given under the free gas capacity options. So the issue here is that when you get any valve from the vendor catalog or you are offered with a valve, for example, if it is provided with the required flow or the capacity of the valve based on the free air capacity, but at that time normally the process engineer does not know whether it will really fit for your required service or not, because you have to compensate it or convert it into an equivalent volume of or the capacity based on the fluid that is stored inside your tank or the vapors that are present in the vapor space of the tank. So this application block is developed in order to validate and to cross check the offered valve from the vendors. So again, two options are provided as I explained. Upon selecting one of the option, basically for the vendor's valve capacity, the user can select again the fluid that is present inside the tank from this drop down menu or a drop down box over here. Then the user can provide the operating temperature and the set pressure of the tank at which the blanket gas is required, and at the last the user need to provide the manufacturer's valve capacity in standard cubic feet per hour, which is based on either one of these two selections, either free air capacity or the free gas capacity. Again, when you provide this information and change any of this input, the calculation will be done automatically, or you can press the calculate button to further calculate the valve size or the capacity according to the provided inputs over here. So again, for demonstration, I will just start the new instance of the application. This time I will run the application block for the vendor's valve capacities verification. Again, I will select the appropriate fluid and then provide the manufacturer valve capacity, and then I will press the calculate button. The calculation or equivalent capacity of the selected valve will be calculated and shown on the right hand side in the results section respectively for each parameter. So here you can review that the actual valve capacity of the vendor's selected or provided valve was 45,000 standard cubic feet per hour, but under the given conditions for a specific fluid that you have or the user has selected from the drop down list of fluid, the actual capacity of the valve is more than 45,000 standard cubic feet per hour, or the actual valve capacity is 42,300 for that selected valve. So if this value is adequate or sufficient or greater than what you have calculated in the above results section of the blanket gas required venting capacity, then it means that this valve can fulfill your requirement for that service, for that tank under the given conditions, and vice versa. So you can change and validate the vendor's valve capacity also within the same application. Once you have done all the calculation and you are ready to print out the results in the PDF form, the user can press the print preview button here. Once you press the print preview button, the application printed result will be displayed in the print preview dialog box, as you can see. So there is a 2-page report will be generated by the application based on the user provided inputs and the results that you have calculated through this application. So once you are okay with the results, then you can simply save the results in the PDF file, or you can print it out straight from the printer by pressing the print button over here. So once you press the print button, the print dialog box will open, where it gives you an option to print the file into the PDF format or straight through your connected system printer. So once you press the print button, then the results will be printed out into the PDF file. As you can see on my screen, the results are printed out in the PDF file. As you can see, later you can use this file accordingly. Now going back to the application, so this is pretty much the main features of this application. Thank you very much for your time and patience. Please like and subscribe my channel. Hope you have liked the video. For more informative demonstration of the videos on my chemical engineering application, please visit my website. Until then, take care. Bye.